Hi, I'm Cheryl Leach. In this problem, we're going to be finding the equation of the tangent line to a given function at a point. After we do that, we're going to be looking at the output values of both the original function and the line that we create at a couple of different points. Not exactly at the given point, but very close to it. So let's get started. In order to find the equation of a line, I need the slope and a point on the line. I have the point, so I need the slope. Slope of a tangent line is the derivative. So the derivative of f is going to be 6x squared minus 2x. And I need to evaluate that at the point -2, -19, which means my input is -2. So f prime of -2 is 6 times -2 squared minus 2 times -2. This is going to give me 24 plus 4, or 28. Okay, now I need the equation of that tangent line. So I'll use my point-slope formula. Y minus y1 equals m times the quantity, x minus x1. Now I'll just insert the appropriate information. So I'll have y minus a -19 equals 28 times x minus a -2. This gives me y plus 19 equals 28x plus 56. Subtracting 19 from both sides, I have 28x plus 37 for the equation of my tangent line. All right, now I said I'd like to evaluate what the output values are for both the original function and my tangent line. Notice at the point 219, in my picture, that's located right here. And that particular point is on both the function and my line because it's at the point of tangency. But I want to see what happens a little bit to the left of -2 and then again a little to the right of -2. So I'm going to let my delta x, or my change in x, be -0.01. So what am I looking for then? I want to find f of -2 plus a -0.01. This equals f of -2.01. Now I need to do a little number crunching. I'm going to take -0.201 and plug it into my original function. So I'm going to have 2 times -2.01 cubed minus a -2.01 squared plus 1. There's quite a bit of number crunching here, so I'm going to go ahead and pull out my calculator to help me evaluate this. So 2 times -0.01 to the third power minus -2.01 squared plus 1 equals -19.281302. It's quite a number. All right. The next thing I want to do is evaluate the output of the line at that same value. So I'm going to plug this -2.01 into my line. So we'll say at -2.01, the equation of my line is 28 times -2.01 plus 37. Again, I'm going to need to do a little number crunching. So when I plug that into my calculator, 28 times -2.01 plus 37, I get -19.28. Now let's take a look at what this means on my graph. So this is the value of my function at -2.01. So I'm a little bit to the left of -2. So I'm looking at the y value that goes the whole way down to that curve. On the line, I'm still at -2.01, but I'm going to go the whole way down just until I hit the line. Now it's very close, but can you see that I've gone down farther on the function output than I did when I looked at my line? Okay? Again, they're very close. The next thing the problem asks me to do is repeat this whole process, but this time, instead of looking a little to the left of -2, I'm going to move a little to the right of -2. So let's begin by looking at f of -2 plus 0.01. This is f of -1.99. And again, I need to take this -1.99 and plug it into the original function. So I'm going to have 2 times -1.99 cubed minus a -1.99 squared plus 1. Once again, I have some number crunching to do, so I'll pull out my calculator and plug -1.99 into my function. So 2 times -1.99 cubed minus a -1.99 squared plus 1. And my result is a -18.721298. All right, it's time to repeat the whole process, but I want to see what happens at my tangent line. So at -1.99, I'm now going to take that same input and plug it into the equation of my line. And I'll have y equals 28 times -1.99 plus 37. Again, some number crunching is required. So when I plug this into my calculator, 28 times -1.99 plus 37, I'm going to end up with a -18.72. Again, the answers are a little bit different. Let's see if they make sense according to my graph. My function value is a smaller number, not by much, but notice that all the numbers match until I hit that third decimal place. So it's a little lower on the graph. And if I moved a little to the right of -2 and I look at that y value, it's going to go down to that curve. And if I look at the y value according to my tangent line, I'm going to come down. And notice I came almost down as far, but not quite. That little bit made all the difference. I hope this was helpful. Thanks.